In this video, we're going to look at the key highlights from Andrej Karpathy's recent autonomous driving talk and explain why Tesla will 10x in the next 10 years because of full self-driving. Welcome to my channel, The Paper Bag Investor, where I'm always looking for the next multi-bagger investment for your portfolio. Nothing on this channel is financial advice, but I have been investing since about 2009 with a 30% compound annual growth rate over that time. Wow. If you get value out of this video, make sure you hit that subscribe button if you aren't subscribed already. And I've also recently started a Patreon, which I will link down below in the description. If you want to support me and my research, feel free to join my Patreon there. As that community grows, I'll be creating more exclusive content for it. Make sure to stick around to the end of the video, as I'll be explaining exactly my plan with Tesla and why I think Tesla will 10x in the next 10 years because of full self-driving. But first, let's look at the highlights of Andrej's talk, and I'll give my commentary.
Quickly speak to the value today that we provide, just to give you some examples of what the team is up to and what we're sort of doing today. So here's an automatic emergency braking scenario. So the driver here is proceeding through an intersection, and you can see trouble coming here. So the person kind of crept up from here, and the car sees the pedestrian, object detection kicks in, and we slam on the brakes, and we avert a collision. Here's an example of a traffic control warning. So this person is probably not paying attention, potentially on the phone, is not braking for the traffic lights ahead, but we see that these are relevant traffic lights. They are red, and we beep, and the person immediately starts slowing and probably does not actually enter the intersection. These are examples from pedal misapplication mitigation, PMM. Here, a person is unparking from their driving spot, and they are trying to turn, and then they mess up and they accidentally floor it. So they floor it right there, and the system kicks in, it sees pedestrians ahead of us, and it slams on the brakes and averts what would be a very gnarly situation in this case. Here's another last scenario I can show briefly. So this person is trying to park, and they turn to the right here, and they intend to press the brake, but they actually floor it. And the system again sees that there's no driving path forward and actually slams on the brakes and averts. In this case, this person is not going to be swimming in this river.
What's great about Tesla's approach to full self-driving is that they offer value right now immediately. Obviously, there's going to be a lot more value in the future, but already it's an attractive offer that makes their vehicles that much better than the competition. And if you want to scale any kind of system or any approach to any really difficult problem like full self-driving, or even like a problem like creating mass electric vehicles, you have to offer value in the present to consumers at that point in time, and then grow with that value over time into the real major goal that you want to achieve. If you think about Tesla, even in the early days, you could go back to 2011, 2012 when the first Model S was coming out. The cars were not as good as they are now, not as good a range, not as good a supercharging network, not as much belief that there's going to be a Tesla in the future necessarily for people that were buying those cars. But it's still, at that point in time, because there was no electric vehicles, it was still a compelling product for those initial customers. There's still value being offered to them. And obviously they grew on that value and expanded from that to the point where now they've reached a mass market status. So it's key to any kind of growth company, any kind of operation, you have to be able to offer enough value now that you can continue to scale. So I love that Tesla actually offers value with their full self-driving now. You can contrast that to a company like Waymo. It's offering very little value to very little consumers right now.
Under the hood, and in terms of the scalability of the system, things are incredibly different. So in particular, a lot of the competing approaches in the industry take this Lidar plus HD Map approach. And so the idea is that you take an expensive sensor, a Lidar, on the top of the car, and it basically gives you range finding around the vehicle in 360 and gives you a point cloud. And what you have to do is you have to pre-map the environment with the Lidar sensor, and you have to create a high definition map. And then you have to insert all of the lanes and how they connect and all the traffic lights and where they are. And you basically have to create a high definition map. And then at test time, you are simply localizing to that map to drive around.
I like to think of the Lidar plus HD Maps approach really is an approach that has no brain, or very, very limited sort of brain versus a Tesla approach is really trying to actually make a neural net, make a brain that understands the whole world around it, can visually see the world around it, and assess and make real-time decisions about the world around it, just like we humans do with our eyes and with our brain. But in contrast, the Lidar and HD maps, Stephen Mark Ryan of Solving the Money Problem, I heard, he gave a really good example. He described it as almost like going onto a railroad track, like you're building these really rigid railroad tracks everywhere, which is the HD map, these perfect HD maps of the whole environment that you're maintaining over time. And then the cars trying to use those, to kind of follow that railroad to perfectly go where it wants to go. But the problem is the real world, anything breaks down with the railroad tracks, you have to repair those tracks, you constantly have to keep them, maintain them, build new ones for new areas. And it's not as simple as actually building railroad tracks. It's trying to map an entire world, all the lane markings, all the lights, all the curbs. So it's a very, very difficult problem, very, very rigid, fixed approach that LiDAR plus HD maps takes, with very little sort of intuitive or actual understanding of the world around it, which in contrast is really Tesla's approach.
And so the approach we take is vision-based primarily. So everything that happens for the first time there in the car based on the videos from the 8 cameras that surround the car. And so we come to an intersection for the very first time, and we have to figure out where are the lanes, how do they connect, where are the traffic lights, which ones are relevant, what traffic lights control what lanes. Everything is happening at that time on that car, and we don't have too much high definition sort of information at all.
And I just love how Tesla's approach is really exactly how we humans drive, with a brain, with vision, the two things working together to assess the environment around us and make real-time decisions.
And what he's referring to is basically like vision is getting to the point where the sensor is like 100x better than, say, radar. Then if you have a sensor that is dominating the other sensor and so much better, then the other sensor is actually starting to like really contribute. It's actually holding you back, and it's really starting to contribute noise to the former system. And so we are really doubling down on the vision-only approach. And actually in this talk, what I would like to primarily talk about is how we have achieved vision-only control without radar and how we have released this quite successfully so far to the fleet.
So Tesla's radar was really just creating noise that caused conflicting results in certain scenarios. So ultimately, they ditched it.
Now, typically when we talk about vision, the reason people are squeamish about using vision is, and the sort of challenge that almost always is pointed out, is people are not certain if neural networks are able to do range finding or depth estimation of these objects. So obviously humans drive around with vision. So obviously our neural net is able to process visual input to understand the depth and velocity of all the objects around us. But the big question is, can our synthetic neural networks also do the same? And I think the answer to us internally over the last few months that we've worked on this is an unequivocal yes. And I'd like to sort of talk about that.
This question, can vision only calculate depth? Fundamentally, I think the answer is very obvious. We humans have 2 eyes and a brain, and we can understand depth just based on how our 2 eyes map the world around us and understand their two points they're looking from. So to me, it seems very obvious that you should be able to do that or recreate that with a synthetic brain that you're building, and then more than 2 cameras or 8 cameras like Tesla has.
So the first component that you need is an incredibly good data set. So and when I talk about a good data set, I believe it has to have 3 properties that are critical. It has to be large in millions of examples. It needs to be clean. So in this case, we have to have a very clean source of depth, velocity, and acceleration for all these cars. And it must be diverse. So we're not just talking about a single, driving clip of going forward on a highway. We really have to get into the edge cases and mine all the difficult scenarios. And I'm going to show you some examples. And when you have a large, clean, diverse data set, and you train a large enough neural network on it, what I've seen in practice is, in the words of Ilya Sutskever, success is guaranteed.
But Karpathy says to build a really good neural network, of course, you need a really, really, really big data sets, but they also need to be large, but they need to be clean data sets and diverse. So you have to get as many sort of detailed edge cases as possible. And the hardest parts of that equation, or those sort of requirements, I would say, are the large requirement and the diverse requirement, because just to get real world data that's huge data sets and really, really, really diverse data sets is really, really difficult to do. But the Tesla, I think they're really the only company out there you could say that meets all three of those requirements, and especially has those two difficult requirements, the large data set and a diverse data set.
Basically, over the last 4 months, we've done quite extensive data engine. And we've ended up doing 7 shadow modes and 7 loops around this data engine here, where on the top right is where you begin. You have some seed data set. You train your neural network on your data set, and you deploy the neural network in the customer cars in shadow mode. And the network is silently making predictions. And then you have to have some mechanisms for sourcing inaccuracies of the neural net. So you're just looking at its predictions. And then you're using one of these triggers, like I described. You're getting these scenarios where the network is probably misbehaving. Some of those clips end up going to unit tests to make sure that we, even if we're failing right now, we make sure we pass later. And in addition, those examples are being auto-labeled and incorporated into a training set. And then as a asynchronous process, we're also always data cleaning the current training set. And so we spin this loop over and over again until the network basically becomes incredibly good.
Again, because of Tesla's size and scale, they can iterate and run full self-driving iterations in shadow mode relative to existing versions of full self-driving of the software that's out there, and relative to how people themselves are actually driving. So this is, to me, this is a perfect feedback loop which drives iterative changes, which is how full self-driving, I believe, will ultimately be solved.
So we have a neural network architecture, we have a data set. Now, training these neural networks, like I mentioned, this is a 1.5 petabyte data set, requires a huge amount of compute. So I wanted to briefly give a plug to this insane supercomputer that we are building and using now. For us, computer vision is the bread and butter of what we do and what enables the autopilot. And for that to work really well, you need a massive data set. We get that from the fleet, but you also need to train massive neural nets and experiment a lot. So we've invested a lot into the compute. In this case, we have here a data set. We have a cluster that we're just building that is 720 nodes of 8x A100s of the 80 gigabyte version. So this is a massive supercomputer. I actually believe that in terms of flops, this is roughly number 5 supercomputer in the world. So this is actually a fairly significant computer here. We have 10 petabytes of hot tier NVMe storage, and it's also an incredibly fast storage. So I believe 1.6 terabytes per second. This is one of the world's fastest file systems. And we have also a very efficient fabric that connects all of this. Because of course, if you're doing distributed training across your nodes, you need your gradients to be synchronized very efficiently. And of course, we are reading all of these videos from the file system, and that requires a really fat pipe as well. So this is a pretty incredible supercomputer. So this is a GPU cluster. Next up, we're really hoping that we're currently working on Project Dojo, which will take this to next level. But I'm not ready to sort of reveal any more details about that at this point.
One of the things I love most about Tesla is that they are so vertically integrated. Every aspect of the entire chain, or of the entire organization, and of the entire sort of value stream is under Tesla's domain and complete control, including their own supercomputers that do the process itself and process the neural network data. And Andrej goes on to talk further about their vertical integration here.
This effort basically is incredibly vertically integrated in the AI team. So as I showed you, we own the vehicle and the sensing, and we source our own data, and we annotate our own data, and we train in our on-prem cluster, and then we deploy all of the neural networks that we train on our in-house developed chip. So we have the FSD computer here that has 2 SoCs, FSD chips here, and they have our own custom NPU neural processing unit here at roughly 36 TOPS each. And so these chips are specifically designed for the neural networks that we want to run for FSD applications. And so everything is very vertically integrated in the team. And I think that's pretty incredible because you get to really co-design and engineer at all the layers of that stack. And there's no third party that is holding you back. You're fully in charge of your own destiny, which I think is incredibly unique and very exciting.
I heard in another podcast previously with Andrej that many full self-driving startups use a third-party group to do data labeling. For example, maybe they outsource the data labeling to another company with a team in another country where labor is cheaper to do the data labeling. But Tesla takes the entire value stream, in-house under the control, vertically integrate every detail of it as much as possible. And this is, again, something I just absolutely love about Tesla, and also is a sign of a fantastic business or business in the making, because the more you can vertically integrate, you have the advantage of being able to adapt faster, react faster, because communication is better between all departments and all groups inside of that one domain or one organization. And you're also able to change details and see details that could improve different various groups that you maybe wouldn't have otherwise seen if they were sort of outsourced to a third party.
Here's another example, fairly infamous example of slowdowns when there are cars going below a bridge. The issue here again is that the radar does not have too much vertical resolution. So radar reports a stationary object in front of you. It's as if like the radar doesn't know that there's like a stationary car in front of you or if it's the bridge above. It cannot differentiate those two.
This is a great example of why radar was removed by Tesla. Radar can't understand if an object in front of you is just a vehicle or even an overpass above the road. So it's possible for vision, and it is possible, my understanding is that vision can do everything radar can and more. So Tesla's thought, and I think it makes sense, is why not just perfect the vision side of the full self-driving and put all your resources there.
Another last example, we have a stationary approach. Again, this is in track testing environment. This is an example of a test that we would run. And we are just approaching this vehicle and hoping to stop. What you see in orange in the legacy stack is that it actually takes us quite a bit of time for us to start slowing. And basically what's happening here is that the radar is very trigger happy and it sees all these false stationary objects everywhere. Like everything that like sticks out is a stationary target. And radar by itself doesn't know what actually is a stationary car and what isn't. So it's waiting for vision to associate with it. And vision, if it's not held up to a high enough bar, is noisy and contributes sort of error. And the sensor fusion stack just kind of like picks it up too late. And so again, you could fix all that, even though it's a very gross system with a lot of if statements and so on, because the sensor fusion is complicated because the error modes for vision and radar are quite different. But here, when we just work with vision alone and we take out the radar, vision recognizes this object very early, gives the correct depth and velocity, and there's no issues. So we actually get an initial slowdown much earlier. And we've really like simplified the stack a lot and as well.
Again, Andrej explains that there are a lot of challenges with marrying the vision and radar stacks together effectively, but that vision on its own, they're confident can do everything radar can do and more, so why not? Why not double down on the vision?
So in summary, what I try to argue and give you a sense of is vision alone is actually, is our finding that this is perfectly capable of depth sensing. It is an incredibly rich sensor in terms of bandwidth of information. And doing this and matching radar performance and depth and velocity is incredibly hard. I believe it requires the fleet because the data set that we were able to achieve was critical in all these performance improvements. And if you do not have the fleet, I'm not 100% sure how you can source all the difficult and diverse scenarios that we did source, because I believe that was critical to getting this to work. So it's hard, it requires massive networks, a supercomputer, and a data engine and the fleet. But all of these components are coming together in a vertically integrated fashion at Tesla AI. And I believe that this makes us sort of uniquely positioned in the industry where we are barking up the right tree and we have all the puzzle pieces to make this work.
In summary, Tesla has all the pieces to make full self-driving happen. And I really think they are going to solve full self-driving. To be honest, though, I'm also not sure who else really in the world or what other full self-driving startup or automaker really has the vertical integration, has the approach to actually solve full self-driving. I'm really not sure who else really is out there. One thing for certain, though, is that full self-driving is going to dramatically change the world. I really believe this. It's going to allow for much cheaper transportation for all as we transition to this electric robotaxi future. And whoever can solve full self-driving is going to deliver a ton of value to the public at large and is going to receive a massive valuation and a ton of value back as shareholders and owners of that company that can do that. And I think there's 4 scenarios with Tesla in particular that could play out. So there's basically 4 scenarios that could occur with full self-driving. These are really the only potential outcomes for Tesla. Is if Tesla achieves full self-driving, or if they do not achieve full self-driving, and then if others achieve full self-driving or others do not achieve full self-driving. And if you think about it this way, so, the very, very best case scenario, if you're a Tesla shareholder, is Tesla achieves full self-driving and others do not achieve full self-driving. That's a best case scenario. And in my mind, this is by far the most likely, because I don't think others, I really don't know any other company that has the size, the scale, the vertical integration that Tesla has to really pull off full self-driving. So I think this is the most likely, and this is why the vast majority of my portfolio is in Tesla, because I think it's a pretty good chance this could happen and occur. And if it does, Tesla is going to be by far the world's biggest company, and a 10x from here is going to be very, very easy to 10x beyond. I think will be very likely for Tesla for the amount of value they would be delivering to the market. The next scenario would be Tesla achieves full self-driving, but others do as well. This is still going to be okay. Tesla's still going to be, I think they honestly could still 10x in this scenario, and is possible. I'm not sure. I wouldn't know if I'd put this as the second most likely, because again, I'm not sure who else is actually going to achieve full self-driving, but still is okay as a Tesla investor. The next scenario would be if others do not achieve full self-driving and Tesla does not achieve full self-driving. So that's, I'm putting as a okay minus scenario. I don't know if Tesla would 10x from here, maybe given enough time, possibly. But Tesla, I still think, would do well over time, because they're still, I think, going to, even in this scenario, we're going to do very, very, very well in the future in vehicle market, just because of their electric vehicle dominance. So that's nobody achieves full self-driving, is never actually happens. And then the worst case scenario is Tesla does not achieve full self-driving, but others achieve full self-driving. In this case, and this would be like the disaster scenario, because basically Teslas could be obsolete to some other vehicle that's out there. But I would put this as by far the least likely scenario of the four. Like, I would say this is almost extremely unlikely that somebody else is out there is going to achieve full self-driving, because I just don't see who could possibly do it, and Tesla does not. So that's why I really think that top tight right scenario that Tesla's going to achieve and nobody else will is the most likely. Then probably second most likely, I'd say nobody achieves it, which is still okay. And then the third is Tesla achieves it and others do. Maybe they copy and follow in Tesla's footsteps fast enough that someone else gets it. That's still okay. And then the worst is that nobody ever, or Tesla doesn't and somebody else does, which again, I think is extremely unlikely. So I think these top three scenarios are combined overall are going to be like 99% of the probability kind of matrix is what I would guess, which is, again, and they're all positive for Tesla going forward into the future, which is why so much of my portfolio is in Tesla. And you got to think in those four scenarios, if Tesla does achieve full self-driving and they're really just operating aggressively and aggressively growing their full self-driving unit and full self-driving fleet, and the number of full self-driving vehicles are out there, it's going to create an extremely powerful network effect for Tesla that I just don't think, I'm not sure that next scenario where somebody copies them and runs in their footsteps is really going to be likely, because you kind of have to wonder at that point in time, if there are robotaxis that exist and they're proven to be very safe, and then there's other sort of startups following in their footsteps that aren't as safe or aren't as sure, could have accidents or could kill you, how are you going to trust those sort of follow-up robotaxis? I think most people are going to demand and want the Tesla robotaxi, or want that software version, which is only going to, of course, that's going to only feed more data into the system and create this runaway network effect that where Tesla becomes the only company that really ever solves full self-driving, because it's such a difficult problem. That's the way I see it most likely occurring. Could be wrong, but that's how I see it playing out. Anyways, thank you so much for watching this video. If you got value out of it, make sure you hit that subscribe button and that thumbs up. I appreciate it very, very much. And remember, it's in the bag.